Electronic basics, supercapacitors. Supercapacitors, also known as electric double-layer capacitors, or electrochemical double-layer capacitors, EDLCs, or ultracapacitors, are electrochemical capacitors that have an unusually high energy density when compared to common capacitors, typically on the order of thousands of times greater than a high-capacity electrolytic capacitor. For instance, a typical electrolytic capacitor will have a capacitance in the range of tens of millifarads. The same size supercapacitor would have a capacitance of several farads, an improvement of about 2 or 3 orders of magnitude in capacitance, but usually at a lower working voltage. Larger, commercial electric double-layer capacitors have capacities as high as 5,000 farads. In a conventional capacitor, energy is stored by the removal of charge carriers, typically electrons, from one metal plate depositing them on another. This charge separation creates a potential between the two plates, which can be harnessed in an external circuit. The total energy stored in this fashion increases with both the amount of charge stored and the potential between the plates. The amount of charge stored per unit voltage is essentially a function of the size, the distance, and the material properties of the plates and the material in between the plates, the dielectric, while the potential between the plates is limited by breakdown of the dielectric. The dielectric controls the capacitor's voltage. Optimizing the material leads to higher energy density for a given size of capacitor. EDLCs do not have a conventional dielectric. Rather than two separate plates separated by an intervening substance, these capacitors use plates that are in fact two layers of the same substrate, and their electrical properties, the so-called electrical double layer, result in the effective separation of charge despite the vanishingly thin, on the order of nanometers, physical separation of the layers. The lack of need for a bulky layer of dielectric permits the packing of plates with much larger surface area into a given size, resulting in high capacitances and practical-sized packages. Supercapacitor technology is the electric double-layer phenomenon that has been understood for over 100 years. However, it has only been exploited by commercial applications for about 10 years. As in a conventional capacitor, in an ultracapacitor two conductors and a dielectric generate an electric field where energy is stored. The double layer is created at a solid electrode solution interface. It is, then, essentially a charge separation that occurs at the interface between the solid and the electrolyte. Two charge layers are formed, with an excess of electrons on one side and an excess of positive ions on the other side. The polar molecules that reside in between form the dielectric. In most ultracapacitors, the electrode is carbon combined with an electrolyte. The layers that form the capacitor plate's boundaries, as well as the small space between them, create a very high capacitance. In addition, the structure of the carbon electrode, which is typically porous, increases the effective surface area.